Today we're going to be talking about medians, altitudes, and mid-segments. These are all pretty easy, guys, but the thing is, they're also really easy to get confused, like which ones are which. So you're going to want to pay attention to what you're doing and make sure you don't confuse them. Okay, so the first one we are going to talk about is a median. A median of a triangle is a segment whose endpoints are a vertex of a triangle and the midpoint, that's the T, midpoint of the opposite side. So every triangle has three medians, and the medians are concurrent. Okay, that does not say congruent, it says concurrent. Concurrent is different. It means that the medians intersect in one common point, and that point is called the centroid. Okay, the centroid is important for physics because it represents the center of mass for the triangle. So if you could imagine like a triangle made out of a piece of sheet metal, okay, the center of mass for that triangle would be at the centroid. So you can see in this little diagram here, I have my three medians. Okay, this one goes from the midpoint of that side. Okay, this one goes from the midpoint of that side to its opposite vertex, and this one goes from the midpoint of this last side to its opposite vertex. Okay, those are our three medians, and the place where they intersect is the centroid. I can do better. Okay. All right, sweet. So here we have our cute little triangle, ABC, and we know that AD is 10x minus 11. Let's label that. 10x minus 11. Okay, and DB is 3x plus 10. Okay, so if we look at the figure, we can see that CD is a median, and so it is intersecting AB at its midpoint. So we can see that these two segments, AD and DB, are congruent. So their measures have to be equal, so we can just set them equal to each other and solve for x. So subtracting 3x from both sides gives us 7. X minus 11 equals 10. Adding 11 to both sides gives us 7. X equals 21. Dividing both sides by 7 gives us x equals 3. Easy peasy, lemon squeezy. Okay, next up, an altitude. Okay, altitude, it's like height, right? Altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. Every triangle has three altitudes. An altitude can be inside, outside, or on the triangle. So here we have a couple of different triangles with their altitudes in red. Okay, you can see here this altitude is on the triangle. Okay, here it's inside. Okay, here it's outside. Okay, and then here it's in again. And each time you can see that it is perpendicular to that side opposite the vertex. Okay, so here we have triangle ABC. It's been drawn for us. We have to draw each of its altitudes. Okay, let's do that. So we're going to drop a perpendicular from the opposite vertex. This one's probably the easiest. Okay, sorry that it's a little bit crooked. Okay, that's one of them. All right, this is going to be harder for Mrs. Voynit. If I had a ruler, I'd be in really good shape right now, but I don't. Okay, there's another one. That's perpendicular, we're going to say. Okay. All right, you'll be able to do a better job because you'll have a straight edge. Oh, okay. I didn't do too bad. All right, so you can see they're all intersecting, and they should be intersecting in a fun point. Okay, that point of concurrency or intersection is called the orthocenter. Orthocenter. All right, that's all we have to do for that one. All right, next. Okay, next. Honestly, when I first saw this word, it looked made up to me, but it's not. It's a real word. It's called a midsegment. I was like, oh, that's just a distractor. No, it's a real thing. A midsegment of a triangle is a segment that joins the midpoints of two sides of the triangle. Every triangle has three midsegments, which form the midsegment triangle. Okay, so you can see here X is the midpoint of QP and Y is the midpoint of QR, and that little mid segment connects them. Okay. Yeah, that's pretty self-explanatory. I don't know that I have a whole lot to say about that. Let's talk about the theorem. The triangle midsegment theorem says that a midsegment of a triangle is parallel to a side of a triangle. So you can see right here that these two are parallel. And its length is half the length of that side. Okay, this is important. Underline that, put stars by it, like do whatever you got to do. Okay, oh, and the parallel, that's important too. All right, so like let's say that if we knew that this guy was 22 units long, then this one would have to be 11. Okay, it's got to be half. That's going to help us a lot. All right, let's keep that in mind and do some examples. So we have here MP is a midsegment of triangle LNO. Find the value of X. Okay, so if this is a midsegment, we know it's parallel. Boop, boop, boop. Okay, and then we know it's half of that side. So we know that X equals half of 16. So X has to be 8. See, easy, important at the same time. All right, what about this one? All right, we know that MP is still a midsegment of triangle LNO. Find the value of X and Y. Ooh, okay, so let's start with the half bit. Let's start with X. We know that 7 is going to be half of whatever this side is. So I can say that 2 times 7, that looks like 27, equals 2x plus 4. Okay, well, 2 times 7, I know that's 14. So 14 equals 2x plus 4. Subtract 4 from both sides. Now I've got 10 equals 2x. Divide both sides by 2, and 5 is x. Okay, that's x. That takes care of x. All right, let's go back up to the definition of a midsegment really quick. Remember that a midsegment, I don't know if that's what I was saying, but that's what I meant to say. The midsegment joins midpoints. Okay, this is really important. So if it's joining midpoints, that means that point P is the midpoint and point M is also a midpoint of the sides of the triangle. So going back down here, we know that these have to be congruent and these are also congruent. So that means that Y has to be 5. Ta-da! All right, let's look at 2 more and then we're done. This might be the shortest notes ever. Okay, so, this is where it gets exciting. We have to find BD and the measure of angle CBD. So we have to find this segment, BD. Well, I can see that this little triangle inside is the mid-segment triangle. Okay, so BD is a mid-segment. That means it has to be parallel to the side AE, and it has to be half of its length. So BD is 1/2 of 17, which is, brain, 8.5. Yeah, 8.5. Okay, now that was the fun, easy part. This part is a little bit more exciting. All right, we have to find the measure of angle CBD, given that this angle here is 26 degrees. CBD is this one. Let me do this one in pink. CBD is this one. Okay, so we're going to extend some lines. Look at this. Okay, these lines, because I've got a mid-segment and a side, they are parallel, okay, which makes the angle that we want, CBD, and this angle that they gave us, BDF, a special kind of pair. Notice that they are on the interior. Okay, they are also on alternate sides of my hot pink transversal. You guys missed the hot pink transversal, I know it. Okay, they're on alternate sides of the hot pink transversal. They're on the interior. These are alternate interior angles and they are congruent. So if I know that the angle BDF is 26 degrees, then so is the angle that I want. So the measure of angle CBD is 26 degrees by the alternate interior angles theorem. You guys thought we were done with that one, didn't you? Nope, it is back. It is back. So back. All right, JL. We have to find JL, we have to find PM, and we have to find the measure of angle MLK. JL. Where is JL? All right, JL is this one. Okay, I see they gave me that PN is 36, and I can tell that this is like a side and it's parallel little mid-segment friend. Okay, so I just have to double that 36 to get JL. So JL is, what is 2 times 36? 72. Okay, that one was easy. PM. Okay. PM is a little mid-segment. Okay, and it is parallel to this LK. Okay, and they're telling us LK is 97, so PM has to be half of that. All right, I'm not doing this one in my head, guys. I'm sick. 97 divided by 2. 48.5. All right. 48.5. So PM is 48.5. Okay, now we get to find the angle. So we're going to do something similar to what we did over here, where we're going to extend some parallel lines and think about what the transversal is. So the angles of interest are the one that we know, they gave us JMP, okay, and they want us to find MLK. MLK is this one. So what I'm hoping that you see is that we need these lines that are parallel, okay? And this side of the triangle is going to be my hot pink transversal. Okay, let's shade the interior because I like doing that. That's fine. And it's helpful. Okay, now if I look at the one they gave me, the 102, and the measure of and angle MLK, they're not both in the interior, they're not both in the exterior, and they're on the same side of my transversal, my hot pink transversal. It's these two right here, this one and this one. Okay, you can see that if I just slide my 102 angle right down here, it lands on angle MLK. Guys, these two are corresponding angles. These are kind of the hardest ones to see, even though they're one of the first ones we learned. They're corresponding and they're congruent. So the measure of, oh my goodness, the measure of angle MLK is 102 degrees. And we know that by the corresponding angles postulate. Okay, that's the end.